it up when you guys are ready.
Perfect,
I'm watching
great.
you guys. And then there's a Q&A mic right there. So check 1, 2.
Perfect.
So I'm going to turn it off.
Hello? All right, just in the interest of staying on schedule, both for people in person and online, I'd like to start the session on normative philosophy and AI. We're going to start with optimization's neglected normative commitments. Just as a reminder, we're going to do a sequence of 10-minute talks and do the questions for all of the authors at the end. So again, optimization's neglected normative commitments, Benjamin Laufer, Thomas and Gilbert, and Helen Nissenbaum. All right, Ben, you'll present from here? Great.
Hi, everyone. Okay, I'm Ben Laufer, and this is recent work on optimization and its neglected normative commitments. And my co-authors are Tom Gilbert, who is in the audience, and Helen Nissenbaum. What is optimization? Optimization is a paradigm used to approach decision-making. It is a mathematical function, and increasingly, optimization is a kind of worldview that people use to approach everyday life. Formally, we define optimization as a way to relate a set of potential decisions to a specific quantifiable outcome, quantifiable goal, and to use this relationship to identify the best performing decision. So here we provide an example of what a formal optimization looks like. Students might be introduced to this notation at an introductory operations research course or maybe in calculus. An optimization problem is composed of a decision variable, an objective function, and a set of constraints. The decision is whatever a decision maker is assumed to have control over. The constraints limit the set of feasible alternatives, and the objective is a way of measuring the goal or performance of a given decision. Optimization represents a systematic way to quantitatively choose between a set of decisions. It is formal, it is flexible, and widely applicable. However, none of this implies that optimization is neutral, objective, authoritative, or legitimate. Generally, we argue that a decision that is called optimal or optimized is not necessarily a decision that is ethically justified. So in the paper and in this talk, we discuss two questions that guide our inquiry. First of all, what are the normative assumptions and commitments that are implicit in the use of optimization? And second, what social problems arise when optimization is used without proper care for ethical considerations? And just for reference, we define neglect as the failure to take proper care for ethical considerations. By identifying failure modes and emergent problems, we hope some set of issues can be avoided as certain uses of optimization come to be thought of as neglectful. So now I'll walk through a typical optimization process to give a sense of how optimization is used in the real world as a paradigm and as a decision aid. We've already talked about what an optimization model is. Now we'll situate its use in real-world systems. In order for optimization to connect and apply to real systems, there must be some assumptions about how observations and details about the world may be operationalized and used in optimization. This inevitably requires some amount of measurement and problem formulation. Once the optimization is loosely specified, it may be intractable or needlessly complex. So optimization will often undergo a series of simplifications, approximations, and solving steps before yielding an optimal solution. This solution is then applied to some real-world operational decision. For example, a transportation agency decides how to route its vehicles, or a social media platform decides which posts to amplify on users' feeds. Finally, of course, this decision has some impact on the world. So in our paper, we map these various steps in an optimization and pick apart all the non-trivial and ethically thorny decisions that are unavoidable when optimization is used in real-world settings. The paper tries to be systematic and goes through each of these steps in detail. In this talk, I'll just provide two highlights. So first, we'll talk about the ways that values get introduced in optimization problems while the model is being specified. Optimization requires specifying at least one decision and at least one measure of utility. When considering how to incorporate a value like fairness, for example, into an optimization, there can be a number of ways to do it. So the question is, how are values and ethical considerations specified, and when are they given improper consideration? First and foremost, values can be omitted entirely from an optimization. A criminal risk assessment algorithm optimized to predict future crime without considering social impacts, including fairness, omits crucial considerations and may therefore be a faulty and unjustified use of optimization. Even if a value is given explicit consideration in an optimization, it can be misspecified, meaning it is given improper treatment either as a constraint or as an objective. A constraint tends to be a categorical rule determining which choices are feasible and ruling out everything else from consideration. Constraints can be trivial, meaning they are introduced but do not actually change the optimal outcome. And when they do come into play, they often lead to an optimal solution that rests on the boundary of a constraint. Objectives, on the other hand, tend to be ways of quantifying utility and tend to evoke a more utilitarian calculation of value. They may require predictions and can often be reductive, for example, by measuring value in dollars. To better understand the different ways that values can be considered as a constraint or as an objective, consider a hypothetical transit agency tasked with providing transportation to city residents. Two different approaches to optimizing transport might yield different results. So in the first approach, the agency decides to contract duties to a private company. The company agrees to certain requirements. For example, it must provide a certain level of access to low-income neighborhoods. Otherwise, the company will optimize for profit, maximize revenue, and minimize cost. In the alternative approach, the city agency itself provides transportation. As a bureaucratic government entity, the agency might eat up as much budget as possible and aim to optimize for access or other performance with the allotted budget. So these two approaches to revenue management would lead to different realities for people in cities, and this toy example demonstrates that the same two considerations, money and access, can be treated either as a constraint or as an objective in an optimization. So now I'll talk about another failure mode that can arise when applying optimization in real-world contexts. This category of emergent problems arises when optimization neglects to consider multiple agents or stakeholders in an optimization. So first, when specifying the objective, an optimization might be designed to only serve narrow interests. For example, the interests of investors might be prioritized over the interests of workers or everyday citizens. And second, a decision model can formalize power relations by presuming that a decision maker has a certain degree of control. For example, social media companies using algorithms to recommend content to users might assume that they can show any post to a user, even posts from people the user doesn't follow. The user, however, might assume that their choice of who to follow dictates which posts they see on their feed. The algorithmic recommendation implicitly removes some amount of control from users and grants platforms and advertisers more control over curating users' feeds. So in total, we identify 6 categories of failure modes: misspecifying values, problematic decision boundaries, neglecting to consider multiple agents, mislabeling and mismeasurement, faulty solution steps, and using optimization as a justification for dubious behavior. We refer everyone to the paper for a discussion of these in more detail. Zooming out, optimization is a widely used paradigm with massive stakes. Optimization methods were first developed for US and Soviet state and military operations. Amidst advances in computing, they have reached virtually every corner of institutional decision-making, including operations and logistics, military, and financial decisions. Optimization also lies at the heart of sophisticated machine learning algorithms and is increasingly used for expediting and accelerating scientific research. Despite its widespread use, optimization makes a number of normative assumptions and can cause harm. So now I'll return to the general point. As optimization is used in these various domains, it is crucial to remember that a decision that is optimized is not necessarily a decision that is ethically justified. The use of optimization can make people assume that a decision is the best decision, all things considered. But this need not be the case. There are plenty of careless and neglectful and even malicious ways of using optimization. Assuming that optimal decisions are good decisions can lead to catastrophic uses of optimization in high-stakes decisions. So my co-authors and I hope this paper is the beginning of a line of research on optimization and its normative implications. Empirically, there are a number of directions for future research. Studies might observe failure modes in practice or identify new emergent problems not discussed in our paper. Documentation methods like model cards, data sheets, and others might help researchers analyze and the setup of high-stakes optimization and pinpoint problematic assumptions. Finally, as with machine learning and other technical systems, biases can be introduced at a number of stages, and work on fairness and accountability in these systems may prove useful. On the conceptual side of things, we're keen to think about what ethical norms and standards might guide the use of optimization towards social ends. We're also interested in thinking about the institutional and system-wide effects of optimization as a practice. So thanks so much for listening, and thanks to everybody who helped make this possible. And yeah, that's it. Thank you.
I'm really excited to introduce Borhain Blue-Hamlin and Leif Hancock-Slee on making intelligence, ethical values, and IQ and ML benchmarks. Thanks so much.
Thank you.
Pretty excited to be here. So our paper is an exercise in learning from the past. We draw on over 20-year-old research that was looking at feminist and anti-racist scholarship on the role of values in IQ research. And we do this to shed light on overlooked areas of ethical risk for machine learning benchmarks. Another core contribution of the paper is thinking about ways in which machine learning research is value-laden, as many folks in this room are already doing very well. And the other contribution we make is to research that's critically examining machine learning benchmarks and evaluation practices. Some definitions before we move further. So the first one is value neutrality. By this we mean not dependent on ethical, social, or political values. Another definition is IQ. By this we mean cognitive tests that approximate general intelligence for humans. And by machine learning benchmarks, we mean data sets together with metrics. Benchmarks often include leaderboards, they're often accompanied by research papers, and sometimes they include competitions. Okay. So this is the slide where we may disappoint some folks who are hoping to hear about benchmarking things like IQ for machines. The core line of research we explore in the paper is instead structural. We focus on structural parallel between IQ and machine learning benchmarks. The thought is roughly that both machine learning benchmarks and human intelligence benchmark set standards for describing, evaluating, and comparing performance on tasks relevant to intelligence. Another key concept in the paper is the idea that in both the machine case and the human case, intelligence needs to be understood as what philosophers like to call thick evaluative concept. Just want to also mention and shout out the keynote from Dr. Alondra Nelson back on Monday, which was also looking at similar notion of thick description. So in this setting, what we mean by thick concept is evaluative terms that also describe empirical features of the world that are independent of our evaluation. And a really helpful example for us to have in mind, especially when it comes to thick concepts that have a major place in social sciences, is the concept of health, where health describes empirical features of organisms, but it also evaluates the desirability or value of the condition of an organism relative to considerations like well-being, illness, and so on. I'm going to pass it on to Leif.
Okay, so Bo just described the notion of thick concept, and now we're going to describe 3 areas where the thickness of both IQ and machine learning mean that there are certain ethical risks that come with defining measures for either of these 2 things. So the first area where there's been a lot of debate in the history of IQ about how to proceed in a value-neutral way. It's how you define your task and select your task when you're creating a benchmark. So this question, this kind of determines what counts as intelligence. It determines what tasks we're measuring performance on. And one lesson that we draw from the history of IQ measurement is that it's well recognized that task selection IQ can encode various value trade-offs. So we think the same thing applies to machine learning. So, for example, in machine learning, what tasks you select can encode, what kinds of effects it has in the world and what counts as a machine being intelligent. So you could prioritize accuracy metrics over other metrics like robustness, fairness, safety. You could prioritize sequence prediction tasks in NLP over other tasks in NLP. And there's been prior work by Roger et al. That argued that it doesn't make sense to have a general benchmark that contains like a general set of tasks. Instead, all benchmarks should be task relative. And we agree with that, and we build on that by arguing that there's no such thing as a value-neutral selection of a group of tasks to serve as a general benchmark. And there are some newer benchmarks now that try and incorporate that insight. So there's a recent preprint benchmark called Helm, which tries to center the value-laden character of task selection by allowing you to kind of like choose different tasks and different metrics based on your values and your desiderata. And we would further say that it's not just that task selection is value-laden, but that good science involves being very explicit about which tasks you are selecting, and shouldn't be just based on technical availability or data availability and things like that. The second area in which we think there's an important analogy between IQ and machine learning benchmarks is how they define validity. So in machine learning, it's very common to define validity purely by what social scientists would call internal validity, because you're almost always using mainly cross-validation to determine whether to determine the performance on the benchmark. But in social science, there's many other notions of validity that are that what we call external validity tries to tries to measure different things like how does your construct correlate with external phenomenon? How does it correlate with other concepts that we care about? How does it predict other things that we care about? And we argue that social, political, and ethical values will determine which forms of external validity you want to you want your benchmark to have. And we draw on a very long history of literature in the IQ case, where they have the same debates essentially about external validity, because they're debating whether IQ should predict health, whether it should predict education outcomes, whether it should predict occupational outcomes. And these questions will determine how you define how your IQ tests or your IQ benchmarks. And so we basically argue the same thing applies in machine learning. We need to consider what kinds of external validity we want, and not just internal validity. So one example is, if you're creating a benchmark data set for detecting hate speech or toxic speech, you need to consider what counts as your benchmark data set being valid, right? Because different people have different experiences of what hate speech or toxic speech is. So the way you annotate your data set is going to depend on what kind of validity you actually want in your benchmark. So then the third analogy that we want to draw between IQ and machine learning benchmarks is this notion of path dependence, which we use that to refer to mechanisms that lock in some kind of historical accident, and then which makes it very hard to switch to alternatives later on. So there's a long history, again, of feminist anti-racist critique of IQ tests that argue that IQ tests create a kind of path dependence, because if a kind of test becomes very widespread, then schools are going to use that test to classify people, and then those people are going to get fewer resources in school, and then they're going to test worse later on in life. So it creates this self-fulfilling prophecy and a positive feedback cycle. And we argue that there's actually a bunch of related arguments in machine learning that argue that the same thing happens in machine learning. So if you create a benchmark and it becomes a very popular benchmark, then it's going to favor certain types of models. It's going to favor certain types of hardware or software that gets developed and invested in. And then that feeds over in itself, and that means that we don't invest in other types of models or other types of hardware or software. The other aspect of path dependence that we think happens in machine learning potentially is that we think it can potentially verify some social constructs. So if we have benchmarks that contain some social categories that just become common social categories in benchmarks, and then those get validated in real-world models that get deployed, then there could be social pressure to conform to those categories because they're widespread in machine learning benchmarks that classify people. And that becomes its own self-fulfilling feedback loop, because then people go out and collect data that's labeled with those same categories, and then the cycle continues.
A few practical recommendations. The first one is addressed at people working on benchmarks. And first, very high-level recommendation is just avoid interpreting performance on benchmarks as value-neutral indicators of capabilities. And also to examine the ethical risks of areas like task selection, validity, and path dependence that we're emphasizing. There's a third one here that I want to really emphasize. Critical position papers about evaluation and benchmarking practices have been very welcome at FACT for a long time, but we want to emphasize that it is incredibly important for venues that are primarily aimed at the benchmarking crowd to also give them a prominent role. So on the ethics review side, the main thing we want to highlight here is we think of this as a hard problem. And so building on past work on this, we feel like there's a need for more knowledge of researcher behavior, of the design space for ethics review mechanism, of how to ensure legitimacy of ethics review. But also thinking about the areas we dig into in the paper, there's just a shortage of examples of benchmarks that thoughtfully center the value-laden character of all task selection, validity, and also path dependence. And we need more knowledge of what that can look like. And also thinking about problems like path dependence, it's important to think about the society level implications. We feel there's a need for structural reforms on how research is incentivized to avoid problems like path dependence. And also there's a need to level the playing field for more diverse approaches to machine learning. Conclusion, last thing to emphasize, we feel like all of the areas we've highlighted are really good science questions. Good science requires being reflective about social, ethical, and political values. Thank you so much.
Could the next speaker come up? Sorry. And I'm delighted to introduce harms from increasingly agentic algorithmic systems, where I hope the authors will introduce themselves. Thanks so much.
Hi, everybody. Thanks for coming out. Yeah, sorry there aren't any names on here. There are a lot of logos because this was a huge collaboration with a lot of the good friends that I've met throughout my PhD. So it's been very meaningful for me doing this project, and I'm super excited to present it to you. By the way, my name is Alan Chan. Cool. So just to give you a bit of an overview what our paper is about, we identify one property that we call agency that we've been increasingly observing in the development of algorithmic systems. We argue that there are huge incentives for the development of algorithmic systems with more agency. We talk a lot about the harms in our paper, and we identify some mitigation strategies. So let's get into this paper. Now, I'm sure all of you are aware that AI development is happening increasingly fast. A lot of things are going on. And with the system that we already have today, there are a lot of super serious harms that we need more attention on in addressing. Harms like the ruining of livelihoods, the reinforcement of systemic discrimination and unjust power relations, privacy violations, and misinformation. Now, a lot of the people in the fact community have done a really good job in identifying clear evidence for these harms. Despite the clear evidence of these real ongoing harms, AI developers are still pushing forward to develop new kinds of systems coming out all the time, as we've seen in the past couple of months. These new AI systems could potentially have new kinds of capabilities as well. For example, the capability to act and plan over longer time horizons, the capability to interact with actual tools to accomplish things in the real world, i.e. the digital world too, rather than just being a chatbot that you interact with and say things to. And also the ability to act autonomously. So AutoGPT is this open source framework that chains together calls of GPT-4 such that all you have to do is provide a high-level goal and the system acts with your computer through APIs to accomplish that goal without any further intervention. So, in response to the appearance of these kinds of systems and new capabilities, many people in the fate and fact community have identified the need to anticipate harms from systems that are coming down the line, in addition to mitigating ongoing harms. Now, when we anticipate harms, we need to be careful not to overhype systems, and in particular, forget that there are a lot of failure modes that our systems still have. At the same time as not overhyping these systems, we also need to make sure not to underclaim what our systems may be capable of in the near future, especially given empirical findings we've found in machine learning, such as scaling laws that give predictable relationships, it seems, between the amount of compute we put into a model and their capabilities. Now, our paper is on anticipating harms from a particular aspect and property that we call agency. To give you a sense of what we identified as agency, and I'll talk later on about the term agency, we have 4 characteristics associated with agency. The first characteristic is underspecification. Underspecification is the degree to which, when you want an AI system or an algorithmic system to accomplish a goal, you don't actually specify concretely how you want that goal to be accomplished. So when you ask GPT-4 to summarize a paragraph, you don't tell GPT-4 how exactly you want the paragraph to be summarized. You don't go into machine code. All you provide is the text specification. The second property is directness of impact. This one is fairly more simple. It's just about the the direct impact that an AI system can have upon the world without human mediation. So for example, GPT-4 just by itself as a language model outputting text doesn't really have as high of a direct impact compared to if you integrate GPT-4 with a bunch of plugins that allows it to do things like interact with Gmail and browse the internet and do a lot of other stuff. The third characteristic is goal-directedness. This is the degree to which we can understand the operation of a system as optimizing a particular quantifiable objective. And the last characteristic is the ability of a system to accomplish tasks that over a long time horizon. So these 4 characteristics might require a bit more explanation and sitting with. To make these a bit more clear, I'm going to go through an example right now. So suppose that we want to, it's like January or something, right before the FACT deadline, and we want to submit a paper and get it accepted at FACT. So what do we want to do? What do we need to do this? Well, we need to do a literature review, right? So first, I'm going to go to my favorite search engine. Maybe yours is Bing. Mine might be Google. And we're going to try to find papers. So we go on the ACM website. We find some nice papers. We put it into our Zotero. And once we've done this, we write about these papers in our Google Doc. And we repeat this process until we're satisfied with the result. And we have a good literature review and a good understanding of the area that we're interested in. Now, how might we get a system with a high degree of agency to accomplish this task? Suppose that we're thinking about a system like AutoGPT. So again, this is GPT-4, but it's chained together, so it's allowed to interact with your computer in arbitrary ways after you give it a text-specified goal. So you specify the goal, write me a literature review on bias in text vision models. You don't say how exactly you want this goal to be accomplished. You don't say where to look. You don't say what to write. All you provide is this goal. The system would have a high directness of impact if it's able to integrate with things like your web browser, with Zotero, and with Google Docs. Already GPT-4 can interact with your web browser, so anything that you can do on your web browser, this system could also do. This system is also goal-directed to the extent that all you do is provide the goal, write me a literature review on bias in text vision models. And finally, and this is a question of capability, I don't think we're necessarily at the stage right now where we can actually tell AutoGPT to write a literature review and it'll be a really, really good literature review. But you can try this. It might be a bad result, but the point is that these systems are getting better increasingly fast. So if the system is actually able to do this and write a quality literature review, because writing a literature review is a pretty long horizon task, it might take days or weeks or months, being able to do this is characteristic of long-term planning. Okay, so now I'm going to address one of the elephants in the room, this term agency, right? When we use the term agency, I want to be really clear that we're not talking about moral agency. We're not talking about consciousness. We're focusing on a particular behavioral characteristic of AI systems. And finally, we're not talking about the abdication of human responsibility when we use the word agency. We think it's totally possible to attribute agency to AI systems at the same time as recognizing that people still have agency in choosing whether to build particular kinds of AI systems or not. Imbuing our systems with what we call agency in our paper is a collective choice that we're making. We might well decide not to make this choice because of harms associated with these systems. What are these harms? So I'm going to go through another example just to give you a high-level idea of the harms we talk about in our paper, but I really recommend going into it for a further discussion. Now, suppose that in the next few years, we get much more capable systems like AutoGPT that companies are able to roll out into a variety of tasks. So such systems might be able to accomplish office-level tasks at the level of an average office worker. So companies would have strong economic incentives to deploy such systems and automate away jobs. In the same way that right now, multinational companies have very, very strong incentives to outsource labor, to the global south. So given these kinds of systems, what could go wrong? Well, you might think, okay, as long as you have supervisors, it's sort of fine, right? But again, we know from the history of capitalism that there are very strong incentives to throw away the supervisors in order to reduce costs. Another kind of problem you might run into is a race to the bottom. So actually, this was originally meant to be a GIF/GIF of Bart rolling down the stairs. This is meant to represent a race to the bottom. So companies have very strong incentives to develop AI systems that succumb to competitive pressures and are better at doing things like subverting the letter and spirit of the law. So to the extent that we're deploying AI systems that are able to accomplish more and more tasks without human oversight, and these systems are getting getting better and better at subverting the law to pursue profit, this seems like a bad thing. So just to give a high-level sort of characterization of the type of harms in our paper then, collective disempowerment is one thing that we talk about. I think a lot of people in the fact community have been interested in this idea of power and have identified the ways in which how we're developing AI systems right now doesn't give power to the right people. With agentic systems, we could be further disempowered to the extent that when we, if we collectively decide to delegate more and more important societal functions like our productive capacities to AI systems, we will have lost meaningful control over the direction of our society. Harms from agentic systems could also be systemic and delayed to the extent that incentives to deploy agentic systems likely exist in a lot of different domains and can be delayed because of long-term planning. And finally, I want to talk about harms yet to be identified. There's a lot of unknowns, especially because we're going really, really fast in machine learning, but the past sort of 10 or 15 years of machine learning has given us increasing evidence that even when we design systems with certain kinds of goals that everybody agrees on, it's still totally possible for us to get out systems that don't accomplish the goals in the ways that we want. This is known as reward hacking and goal misgeneralization. There's a huge amount of evidence from this in machine learning, and we need to be careful about the ways in which AI systems may act in ways that we don't intend. Now, I've talked a lot about the harms. I'll finally finish with some of the ways that we identify in the paper to preventing such harms. The first is monitoring systems. So we could do things like trying to identify what exactly our systems are monitoring or optimizing for, building on important work in the fact community like model cards and data sheets. Secondly, we can decide not to build agentic systems if we agree that the harms of agentic systems outweigh the benefits, just as we've decided collectively not to pursue certain applications of machine learning into particular areas. And finally, we should be improving public control and oversight over the development of AI systems in general. So this could look like things like regulation, but this could also look like things like controlling the key drivers of AI development, like compute and data. I want to finish by emphasizing that the development of agentic systems is a collective choice. It might seem like we're going very fast and we don't have collective control, but we need to remember that we do and assert back control from unaccountable actors that are imposing negative externalities on all of us. Thank you.
All right, thank you for that. So we've got one more in this session on the site of predictive justice by Seth Lazar and Jake Stone. And I've got your window. Some very straightforward slides.
All right, so this is how you know you are in a one focused on philosophy, is that I'm not doing slides. I've got a handout for you. I didn't want to print one, obviously, but you can go to that URL and you'll find the handout for this talk. Yeah, thanks, Abigail. This is a paper that I've written with my co-author, Jake Stone. I'm just going to start a timer for myself here. Okay, so one of the things that you can do as a philosopher working in this area is you can sort of help to try and figure out like, what are the grounds of our normative critiques of the various different things that we're criticizing? Like, often some of the work that we do will sort of lean heavily on shared agreement about normative premises rather than going into those foundations. So this paper is an example of that. We're trying to get into the grounds of what goes wrong when machine learning goes wrong. So, looking at the topic of algorithmic fairness that's been central to the fact community over many years, what are the real kind of foundations of the moral critique that we're making? And what we wanted to do was to identify a distinct ground of critique that has been sort of under-recognized, that helps to explain and maybe to sort of find a way out of certain types of disagreements that there are among people about how to deal with the wrongs of algorithmic systems. So to start with this, we're going to draw a kind of a fairly stark and slightly caricatured contrast between two different approaches to thinking about the evaluation of algorithmic systems, predictive models, and the decisions that they are used to make. So the maximalists on the one hand say that the maximalists about algorithmic fairness say, look, forget about these sort of abstract and idealized criteria of statistical fairness. Let's concentrate on building just societies, not just algorithms, right? That's a view that many people have heard here many times. Another kind of minimalist view says, look, we should leave the societal costs of these systems to policymakers. model developers should focus on model performance. We should evaluate our models against epistemological criteria, epistemic criteria, rather than doing so against moral criteria. That's something that we apply to the decisions that the models are used to support. And what we do in the paper is we show that moral standards also apply to predictive models. They're not only subject to epistemic standards, and those moral standards, importantly, are distinct from the standards that you find that are applied to the decisions that these models are used to support. So we argue for a site of predictive justice that is distinct from outcome justice and procedural justice. It's not as important as outcome justice and procedural justice. What you do with the model matters more than the moral evaluation of the model itself. But it's still an important thing to pay attention to. And importantly, it's something that is within the proper kind of realm of authority of the people who are making the model. Right? And sometimes the call to build just societies rather than just algorithms leads to a kind of a collapsing of that type of democratic authority and a sort of technocratic approach to rule through the algorithm itself, which we think is independently problematic. Okay, so in the paper we have we draw this distinction between predictions and decisions. The paper is about predictive models generally. It's not specifically about machine learning, but obviously machine learning is the occasion for thinking about this. We normally think that epistemic norms constrain predictions and moral norms constrain decisions. Moral norms like the categorical imperative, for example, or epistemic norms like the Kolmogorov probability axiom. But there has been in philosophy in recent years a sort of growing argument that there are actually moral norms that constrain epistemic practices. So a few different versions of this. You might be familiar with Miranda Fricker's work on epistemic justice, for example. And we want to argue that norms of predictive justice are, in fact, a kind of subspecies of these types of norms of epistemic ethics. This is something that a number of people have kind of floated in papers in the past. What we've done is really try to kind of work through the implications of it and develop the first steps in a theory of predictive justice. And in particular, we wanted to do so in a way that kind of moved away from this, what we kind of call slightly pejoratively, like this cosmic approach to justice that one finds often in moral philosophy, but also in the computer science literature, which tries to identify kind of a principle that applies to the intrinsic properties of a predictive model, such that any model with those intrinsic properties would be unjust or just, irrespective of whatever the background context is. Like our approach to predictive justice is a situated principle of predictive justice. So we give it in the paper. It's a prioritarian performance principle. So very simply, we give a necessary condition for predictive justice. Very simply, the idea is that when you're evaluating model performance, you should give greater weight to its performance for members of disadvantaged groups. This is something that I think would feel very intuitive to people working in this field. But we show that that is a moral principle that applies to the evaluation of predictive models, and it is grounded in a concern with background structural injustice. Right? The idea that underpins it is that we inhabit societies where there is background structural injustice that is in part sustained by our epistemic practices, in particular the ways in which how we model the world is centered on the experience of certain advantaged populations, so that it's routinely predictable that these models will perform better for those for whom they are designed and who are centered in that design. This is we're not making any claim to novelty with the empirical insight. What we're showing is that basic empirical insight implies that you have both kind of remedial, backward-looking responsibilities, not to participate in kind of these reproducing these unjust cultural schemas. You also have forward-looking responsibilities not to contribute to them, as well as a kind of static responsibility not to be associated with them, not to implicitly endorse them. So in the paper, what we do is we give the foundation to predictive justice, we defend the principle, we then kind of look at how to think about degrees and kinds of predictive justice. What makes one case of predictive injustice worse than another one? And one thing that we really focus on is that it really matters the degree, what has caused the reason for the model performing worse for the disadvantaged groups versus the advantaged groups. Right? That background of what has actually led to that model performance being different is something that we really need to pay attention to. And this again is something that if you think about the types of papers that identify, for example, tensions or impossibility theorems between different principles, they often focus on cases in which the difference in model performance for different groups is due to what we call an innocent statistical artifact. Often this is the phenomenon of inframarginality, the fact that one group might be clustered around a threshold, while with the other group there's greater degree of variance. And there are cases in which that can be genuinely morally innocent in the sense that nobody is responsible for it. It's not something that anyone could have done anything about necessarily. But then obviously there are other cases that many people in this community have highlighted many times where the reason the model performs worse for the disadvantaged group is because it has been trained on the socially unjust past. So it kind of carries the taint of that injustice through to the practice of using the model. And we think that's one way you can tell sort of the difference in the degree of injustice. And it means that it's really then important to figure out, like, is it really the case that this particular differential in performance is due to an innocent statistical artifact, or is it in fact due to something about the socially unjust past? And what we think is that in practice, it's actually going to be fairly unlikely that you would have a purely innocent statistical artifact explaining differential performance. Even in cases where, when people talk, I think this is in a way the sort of the North Point kind of response to the ProPublica criticism was that, like, oh, well, these base rates, that's something that's kind of beyond our control. But it's like, no, they're obviously, the difference in base rates of rearrest are obviously due to background structural injustice in the carceral state. As well as identifying degrees of injustice, we talk about different ways and sort of the different kinds of injustice that are at stake. So on the one hand, we talk about how unjust is the model itself. An analogy would be like how racist is a statement, but then also how unjust is it to endorse a predictive model, right? So an analogy would be how unjust is it to believe a racist statement. And we think that the degree to which it is unjust to endorse a predictive model is very much a function of the social power of the institution that's doing so, right? So that's a really important vector to pay attention to. And if you develop a model that is predictively unjust, but you're doing so in order to kind of demonstrate that some company that is using the same model is acting in a way that is unjust, then you've made a thing that is unjust, but you haven't committed an injustice. You haven't wronged anybody by making that model. And that's an important distinction that needs to be drawn. So this is all to show that the way in which we can defend moral principles for evaluating predictive models that are clearly distinct from the evaluating the decisions that they lead to. That's an important thing to do. We think that if you build your evaluation of the decisions too much into your evaluation of the models, you get a kind of circularity. You're justifying the decision on the basis of the predictions, but you're justifying the predictions on the basis of the decision. That's problematic. We want to find ways of separating these things out. But at the same time, we think that it's really important to show that you can endorse an approach to the moral evaluation of predictions that isn't separated from that kind of those theories of background structural injustice. It's not like an either-or thing, that if you go down this path, you're kind of necessarily forced into thinking about cosmic justice, focused only on the intrinsic properties of these systems, without regard to those sort of structural contexts. Okay, so we think this is clearly not the most important aspect of what goes wrong when machine learning systems go wrong. If you're incarcerating people, if you're making decisions about healthcare that lead to people living or dying, that matters a lot more than whether your model is predictably just or unjust. But we do think that it is important, and one thing that we think is especially important about it is that it is the proper responsibility of those developing and designing the model. Where with these other things, they are, it's all of our responsibility as citizens to be part of making these decisions, but we worry that if you try to do too much of building just societies through your algorithms, you're actually arrogating too much power to the machine learning engineers that should really be in the hands of democratic societies. So that's all. Thank you.
Thank you so much for that. I'd like to encourage all of the speakers to head up to the stage. Those of you that have questions in the room, I encourage you to stand up and line up for one of the microphones. Otherwise, you can enter your question online on Hopin, and I'll be monitoring that. But I'll just start by saying I'm very happy with this sort of nicely collected set of papers that all really thought about sort of hidden assumptions in models and the role of in whether it's for science, for machine learning, and the design or use of that. So I'll defer to the first question in the room.
Hi, my name is Virginia Dignam, Umeå University. I have a question to the benchmark paper. Yeah. One of the issues on benchmarks, of course, like you well said, is that you will start optimizing or defining intelligence or whatever it is in terms of the benchmark. But of course, one of the issues that would need to be taken into account in the benchmark, especially if we are going to use it to really measure the the level of intelligence of the AI system or something like that, is also the issue of costs, not only computational costs, but also, of course, human resource costs and other types of costs. So how do you see the benchmark being able to take those multi-dimensional ways of measuring whatever you want to measure in the benchmark in a way that takes into account the implication of the costs, for instance?
So yeah, we actually do discuss the cost bit a little in the paper, because one of the findings is that some of the NLP benchmarks, if you actually correct for computational costs, like if all the different models use the same computational resources, then actually like the best performing model doesn't perform the best because you didn't correct.
Exactly. Yeah.
So that's one thing that I think can be addressed in a few ways. The first thing is that like we should maybe have some kind of documentation system for each benchmark, like benchmark cards, like model cards or benchmark cards, where like where you actually state all these like relevant things, like you know where you force any model that is trying to beat the benchmark to actually state explicitly how much computation resources you have, which currently is not a requirement. So like nobody knows like how much money you spend. And then the second thing is that I think we can learn something from the Helm benchmark, which is explicitly multidimensional. They don't include costs in there, but I think we can kind of adopt that and then include this additional dimension, computational costs, environmental costs, all these things as additional metric, and that you can choose to prioritize or not based on whether you want.
Do you think we can afford to have benchmarks which don't take into account cost?
I think we can't afford to, but I don't make the decisions about like how we do these things. So yeah.
Okay.
Hi, I'm Fala from NYU. I have a question to the last speaker. I'm trying to understand what you're proposing as like the site for predictive justice and how it's different from like Rawls's difference principle. Is it just like an expansion of those notions beyond just like distributive context, or is it something beyond that?
Yeah, good. So the principle itself is prioritarian. So and one way of describing Rawls's difference principle is also as a prioritarian principle. So it has the same kind of motivation. Rawls's principle applies to the distribution of income and wealth, and ours is applied to the kind of the measurement of how we prioritize the performance of the model. So they're kind of applied to different things. Ours is applied to the kind of the evaluation of epistemic performance. His obviously is applied to kind of the actual context of distributive justice. So it's applying a very similar principle of justice to a different site, in the sense that the target of our theory is the evaluation of the model itself, as distinct from the evaluation of the model's impacts on society.
Just to follow up to that, is that meaningful to make that separation?
Yeah, so look, I think that the paper that we're alluding to with our title, there's a paper by Jerry Cohen in response to Rawls, which is called Where the Action Is on the Side of Distributive Justice, where he's talking about how Rawls focuses on the application of the difference principle specifically to the basic structure of society. And Jerry Cohen argues actually for a cosmic principle of justice that says it applies to kind of everything, but still with respect to the distribution of income and wealth. Whereas what we're talking about is like a completely different site again that isn't about the distribution of goods or resources or well-being, but it's specifically about how we evaluate the performance of predictive models. So yeah, it is a very sort of clearly distinct kind of area to apply these sorts of norms to. And it's an area where the sort of standard approach is to apply epistemic standards with, some sort of leavening of kind of moral standards through the kind of values in science type literature, but not in this sort of way of having a kind of a fully fledged kind of distributivist prioritarian approach to how we evaluate performance.
Okay, thank you.
Also a question for Seth Lazar. So I like the diagnosis in certain cases, but I wonder if it should be used to apply to all. So I take it that there's an assumption that it is better if the model performs well for certain groups. And in particular, it's better basically if we can know more about certain groups and better epistemically. But I wonder if that's right. I mean, it just doesn't seem like being known is something that is always going to be better, basically. And one instance, purely from the epistemic perspective, forget about effects, might be something like privacy concerns. So I've just got like a ton of data on a lot of people we might actually not want the model to be better for me to infer all sorts of things about, marginalized populations. It might be actually better if we just sort of let things lie there. Anyway,
yeah. So we talk about this a lot in the paper, and we've gone back and forth and. Oh,
say who I am. Sorry, Milo Phillips Brown. I'm from Oxford.
Hey, Milo. Yes, so talk about this a lot in the paper. We consider a few different possibilities, right? So one possibility is like that you have an interest in being accurately represented. That does not seem plausible, right? That kind of interest-based approach to the view doesn't seem to work. We think that like the background idea is that this under sort of misrepresentation of marginalized populations is part of what has sustained and caused and contributed to structural injustice, and it is the sort of the set of cultural schemas that further reproduces them that one doesn't want to participate in. One has reason not to do that, independent of the downstream impacts. The downstream impacts are going to make a difference to how you evaluate model performance. So we totally buy the kind of values in science type literature around like differentiating between type 1 and type 2 errors, those sorts of things. Like it's not always going to be, you don't always measure performance in the same way because how you are ultimately going to use the model does then have an impact on what kind of performance matters. So we talk about that, we incorporate that into the paper, but we think that even once you've done that, it's still there's still something that matters that, if you're producing models that are continually worse than for the disadvantaged groups than they are for better advantaged groups, and especially when that is due to the fact that like the model is infected by the socially unjust past, that is still and you then endorse that model, that is still a pro tanto wrong. In some cases, it might be a sort of a pro tanto wrong that is totally washed out by the fact that the model actually benefits people.
Excellent. I'm actually going to take a question from online about the agentic harms paper. So regarding the agency of AI systems, could you briefly describe why you retain the term agency while simultaneously disclaiming many common definitions? The principal agent problem was framed in terms of two humans with shared meaning making. How does this work when the agent does not have a meaning making capacity?
Sorry, what was the last part? When the agent does not have...
About the principal agent problem, about how when the agent does not have meaning making capacity.
Meaningful what capacity?
Meaning making.
Oh, meaning-making capacity. Okay, yeah. Yeah, this is a really good question, thanks. So I think there are a bunch of reasons. The first reason is that agent is so I come from a machine learning background, and agent is the term used particularly in reinforcement learning and machine learning to describe the types of systems that we describe with the 4 characteristics that we talked about. So it's the term that I guess made the most sense to us amongst all the authors. There was definitely a lot of debate about it, and certainly I think it totally makes sense there's disagreement over this term. The second motivation actually does come from the principal agent sort of literature. So there's some work from, I think, Dylan Hatfield-Manel and Gillian Hatfield connecting the principal agent problem to the type of problem that we're discussing about, where we're deploying systems that are able to act more and more autonomously. So there they sort of frame this problem as, we have a system, we don't really understand what exactly it's doing. It might have more power over us in certain circumstances, like having more access to resources or having more fine-grained information about particular circumstances, and yet, there might be divergent incentives as well. So for us, this also seems to map very clearly onto the principal agent problem, but also happy to talk offline more about this. Okay, yeah. Follow me on Twitter, and yeah.
Hi, first of all, thanks a lot to all the very insightful talks. I have a specific question for Benjamin, for the first author. And I was wondering if you could elaborate a little bit on the following idea. So in the paper you mentioned that one of the specific issues are feedback loops as part of problematic decision boundaries. And I personally think that it's really important to shift the perspective to take long-term dynamics into account. And I think that adds a lot of complexity, and I also think that it also shifts over to some of the other issues that you mentioned. So for example, when you were mentioning the difficulty of defining values, I think values can also change over time. The same is true for agents or stakeholders. They can also change over time. So I was wondering if you had any thoughts on how to address maybe those other issues once you change your perspective from a static to a dynamic system. And actually, listening through all the other talks, I felt like all of the speakers somewhat touched on that. So Leaf talked about self-fulfilling prophecies. Ellen talked about delayed harms and long-term objectives. And then Seth was talking about these forward-looking responsibilities. So if time allows, I would actually be interested in the opinions of all of the speakers, but maybe we can start with Benjamin. I'm Joachim Baumann from University of Zurich.
Thanks so much. Yeah, I think it's a great question. I think sort of where we were starting, so my background is in operations research, and where we were starting was sort of the practice of optimization as a, like disciplinary mathematical tool. And I think what's interesting about optimization is it offers this artifact where in order to specify an optimization, you have to write out what is the objective, what are the constraints, what decision is being made. And so that creates like an artifact that represents a decision at a single point in time. And so, yeah, it came up a lot in conversations with Tom and with Helen, my co-authors, about how to describe, how the boundaries of the decision can sort of cover up social issues or harms that we might care about. One of them being that decisions can happen sequentially over time, and there can be sort of feedback effects and problematic dynamics, which a lot of people at FACT have written about. I think in the way of solutions, I don't have all the answers, but Tom has been working on documentation efforts, thinking about when things are dynamic, when there are dynamic effects, how do you sort of periodically or in a dynamic fashion document what's happening so that you have artifacts for more than just one point in time. I think there's a lot more work to do on how to think about these kinds of dynamics, and I think FACT is a great place to think about those things, but that's what comes to mind on first thought, but it's a great question.
In the interest of time, I kind of want to give the questioners the last word. So if we could have maybe the next 3 questioners just come up and introduce themselves, give their question, and then we can have some offline milling after the fact. Does that sound good?
I'm sorry, I'm a little...
So introduce yourself, ask the question. They're not allowed to answer, just questions.
Okay. Shannon Valor from the University of Edinburgh. The question is for Seth. So it's just a question requiring some clarification on the notion of disproportionate in the principle, which I think obviously could be understood in a number of different ways. And so I was curious what the condition of proportionality is here, whether it's relative to the harm that's entailed, or whether it's a purely kind of quantitative proportionality that's relative to the increase or decrease between the two kinds of performance.
All right, next question. Thanks.
Hi, I'm Ana Valdivia, University of Oxford, and I have a question also for Seth. Maybe it's a very provocative question. Don't you think it's problematic to say in a paper that we will not argue for or against machine learning? And also, don't you think it's like too narrow to focus on, like, to divide, to classify critiques on, I think you say maximalist and minimalist? Don't you think that, reality is not black or white, has like grays? And as a critical scholar, I think there are like grays in this community.
Next one.
Hi, I'm Julian Michael from NYU, and I'm sorry we're all bullying Seth now when he has no opportunity to respond, but I have a question about moral encroachment. So I'm not an expert in this, but my understanding is that if you bring moral considerations into epistemic standards, then you do run into situations, under most circumstances, you run into situations where you might have to suspend a belief or commit to a belief in spite of contradictory evidence. Otherwise, maybe it wouldn't be meaningful to say that we're incorporating moral norms, right? Moral considerations. And you seem to kind of conveniently sidestep this issue by addressing the rate of inaccuracy, right? So you're kind of like trying to look for some convergence here, but actually, Shannon, I think, kind of made a good point about disproportionate. I think that's kind of where the real kind of rubber meets the road, because if you're talking about any situation that's not like a Pareto improvement, then you have to have some kind of like way of evaluating the trade-off. And so I'm wondering how you think about how epistemic standards trade off against moral considerations when they come into conflict in our understanding of disproportionality there.
All right, thank you so much to the speakers, especially to their no ability to respond. So I'd like to thank everyone for the session. Thank you so, so much.
Nossa,